Okay, so we finished focus question E, and to summarize, the mass number is protons and neutrons. Most of the mass is in the nucleus. So that mass number is pretty much what the atomic mass is. But the atomic mass, if you look it up on the reference table, is a decimal, not a whole number like the mass number is. So that atomic mass comes from the weighted average of all of the different isotopes. So we had learned yesterday that isotopes are two versions of the same element. So they're the same element, so chlorine and chlorine, so they have the same atomic number and the same number of protons. But they have a different mass number, so they have a different number of neutrons. So the atomic mass is an average of those, but it's not just a flat average. Like we don't just take 35 and 37, add them up, divide by 2 and get 36. It's a weighted average. So because there's more of chlorine 35, it's closer to 35 than it is to 37. So if we were to look up, if we Googled chlorine 35 is 76% and only 24% is chlorine 37. So in order for us to figure out this weighted average, it's as if there's 76 35s. So we do 76 times 35. Just like up here, if we were calculating an average, we would take 4 of the 90s. So we get that number. Then there's 24 of the 37, so we do 24 times 37, and we get that number. Then we add these two numbers together. Just like up here, we would take 4 times 90 plus the 80, add them all up, and then we divide by however many there are. So in this case, we divide by 5. In this case, we divide by 100 because we're basing it off of percents, 76%, 24%. So if there was a total of 100, there'd be 76 and 24. Divide that out, we get 35.48. And we know that the one on the table says 35.5. So we already kind of know the right answer, and that's how it's calculated. So we're going to practice the back questions. All right, so if we look at the first one, it says most carbon atoms are carbon 12. So 98.89% are carbon 12, while the remaining 1.108 are carbon 13. So we would expect that the average atomic mass would be closer to 12 because 98, almost all of it is carbon 12. So if we look up on the reference table, go ahead and look on your reference table. The mass of carbon is 12.011, I believe. So we kind of already know what the right answer is going to be. Now we're just going to show how we do it. So just like on the page before, we take the percent and we times it by that mass. Take the percent and times it by the mass, and then get those two numbers and add them together. So we're going to take the percent, 98.89, times 12, and 1.108 times 13. We're going to get those two numbers. So this is 1,186.68. This is 14.40. We're going to add those two together. We get 1,201.084. We divide by 100 because we have 100, and we get 12.01 AMU, which matches what we see on the table. Okay, so you take the percent, you multiply by the mass, you get the number, add those numbers together, and then we divide by 100 because it's based out of 100. All right, so let's look at number 2. Element X has two isotopes. 72% has a mass of 84.9, and 28% has a mass of 87.0. What is the average atomic mass of element X? So this time we can't look up what it is off the table because element X isn't a real element. They're just making it so you don't already know what the answer is. But we do the same thing. We take the percent and we times it by the mass, the percent and times it by the mass, and get those two numbers. So if I multiply 72 times 84.9, I get 6,083.28. If I do 28 times 87, I get 2,436. I'm going to add those two together. I get 8,519.28. Divide by 100, and I get 85.1928 AMUs. Okay. And remember, anytime along the way, you can stop the video and then go back. All right, number 3. There are 4 isotopes for strontium. So here's the different strontiums. Remember, they're all going to have the same atomic number, but they have different mass numbers. Calculate the atomic mass of strontium. So we're not going to look up the number first this time. We're going to look it up after. So we can see that 82% is strontium-88. So we're going to expect it to probably be close to 88. Little bit lower since there's some that's less than 88. So a little bit lower, definitely not higher than 88. Definitely wouldn't be close to 84 because there's only 0.% of that one. All right, so we're going to take the mass number and times by the percent, the mass number and times by the percent, the mass number and times by the percent, and the mass number and times by the percent. And we're going to get those numbers. So we get 7,267.04, we get 609, 847.96, and 47.04. Okay, so we're going to add those all together. We get 8,771.04. I'm going to divide by 100. So we get 87.7104 AMUs. And then you should look up, we said it should be close to 88 because that's where the most percent was. We got 87.7. So now go ahead and look on your reference table and see what the atomic mass of strontium is. And it should be close to 87.7104. All right, and then the last one, these are isotopes of neon. So we have neon 20, 21, and 22. This is their actual atomic mass. Those are the mass numbers. And then 90% is going to have a mass of 19.99. So we're going to be expected to be closest to this. 0.3% of this one, so very little of that one, and 8.8% of that one. All right, so the first question says, in terms of atomic particles, so it has to talk about the particles. One difference between the isotopes of neon. So remember, what's the same about them is the number of protons. Difference is the number of neutrons. Okay. And you could say a different mass number. That's not going to be right, though, because it has to be talking about atomic particles. So even though, yes, they have a different mass number, they want particles. So the particle that's different about isotopes is the number of neutrons. All right, looking at the percent abundance of each isotope, the average atomic mass of neon is closest to which whole number? So since this one is 90% of this one, it's going to be closest to the whole number 20. And then last, the average atomic mass. So we're going to take the atomic mass times the percent and get a number. Atomic mass times percent, get a number. Atomic mass times percent and get a number. So we get 1,800.8991. We get 6.297, and we get 193.512. We add those all together. We get 2,000.7081. We divide by 100, and we get 20.007 AMUs, which is what we predicted we would get. Okay. So that is atomic mass, weighted average of all the naturally occurring isotopes.